am a developer at Possible Mover, which is why I have this shirt, and that's going to get annoying. Possible Mobile is a dev shop, works on a lot of apps you've probably played with and probably seen at an iOS OS keynote. We are always looking for developers. This is I have to do this part. Always looking for developers of every level. So junior, senior, anywhere in between, iOS, Android. If you're one of those people, that's fine. I'm not discriminating. You know, we all make choices. So, confusion optional. We're going to talk about optionals. I am from Atlanta. I'm a native, which explains the ridiculous accent. So if at any point you don't understand anything I say, I will talk much more loudly and slowly at you. Cool? All right. I'll make a deal. I won't do any live coding if you guys don't take an excessive amount of notes. Fair? Okay. So let's get this part over with. The obligatory puffy and take picture. All right, we're done with that. Let's get on with it. So we're going to talk about optionals. Optionals are a very important feature of Swift. If you've ever played with any other languages that are heavily functional or are functional languages, you're going to run into the idea of an optional. It's called different things in different languages. Haskell, I think, is the closest with the option or maybe. But it's very important. And what I found as I was learning, I couldn't find a really good explanation. I'm not the most clever person in the world, so I kind of like things broken down. So this is sort of the result of me trying to learn something well enough to be able to teach it to others. Because I don't really feel if I can't teach it, I don't really understand it. So here we go. So according to the Majors Matrix of Mental Manipulation, the M4, a registered trademark of this presentation, things are either easy or hard, or they are simple and complicated. And of course, optionals, they're not really hard, but they are slightly complicated, so just keep this in mind. We're going to cover what are optionals. Pretty easy one. Why do they exist? Why do we have this idea of nil? What are they under the hood? This is very, very important and will actually help you understand a lot of things about optionals. How do we actually use them? And so let's get into the meat, if you will. We're going to look at how they're initialized, how they're unwrapped. Optional binding, you know what it is, you don't know what it's called. No coalescing, you've probably seen it and didn't know what it was called. Optional chaining, you've used it and didn't know what it was called. Implicitly unwrapped optionals, you've seen it and you didn't know it was called this. And we're going to cover some various odds and ends. So, what is an optional? According to our friends at Apple, it's a way of saying there is a value and it's equal to this, or there isn't a value at all. So I have something or I have nothing. Not in I have something or I have zero or an empty string. I have something or I don't have anything. So you may be asking, are these a replacement for nil? And according to the brilliant mind of Reverend Lovejoy, yes with an if, no with a but. So, show of hands, who here has used Objective-C? Hold on, okay. Who here is new to Swift? Okay. So, let's set the Wayback Machine to Objective-C, which, fortunately, in Atlanta, the Atlanta office, we switched entirely to Swift. Every now and then a project will come up that's Objective-C, and it's like a bitch fest to get the person to just like shut up and get on with it. It's like, it's Objective-C, it's not like you're writing Perl. Let's just get on with it. So, sorry if I offended any Perl users out there. So the idea of nil and Objective-C, it's a way of saying zero. We don't have anything really useful. But the one big difference, one of the two big differences between Swift and Objective-C. In Objective-C, if you send nil a message, it just goes off into the ether. It just disappears most of the time. There are examples we won't get into. But for the most part, the system is set up to say, oh, you're trying to send a message to something that don't exist. And never mind, I'm too busy to worry about that. The one drawback is in Objective-C is nil only applies to objects. Makes sense. It's an Objective-C. It's an object-oriented language. Therefore, objects, right? Well, nil in Swift is a very different beast. In Swift, nil means nothing, the absence, the lack of space, the final frontier kind of nothing, right? It doesn't mean zero if it's an int. It doesn't mean an empty string. It means there's nothing here. Get on with your life. Swift is a very strict type system. The compiler wants to know what this is supposed to be. And what it can be a standard type. It can be something that conforms to a protocol, but it needs to know what it is. So saying, there's something here, maybe it's there, maybe it's not, but it's nothing. Nothing is a problem, because it's like that. It's like Bob from accounting. There's a little bit uptight. I hope there's no one named Bob from accounting in here. But it's the sort of person that you turn in the receipts, and they're like, I know it's only one item, but I need an itemized receipt. It's like, well, no, Bob, take the red stapler and go back. So that is the Swift compiler. Just think about it, Bob from accounting. It'll hit you. So since the compiler and the analyzer are constantly running in the background to see what you're screwing up, if it hits something that doesn't work, it's going to say, no, hey, you got to fix this. Do you want to use exclamation? Do you want to change this to all those generally useless recommendations that it makes? It's going to be a problem. It will tell you. But that's good. That's good, because if you're running it and you hit a nil, you're actually going to crash. And it's better to crash before you even run it than when someone else is running it. General philosophy. But one of the good things is nil applies to everything in Swift. It's not just objects. It's not just this class may or may not have an instance. It's anything. It's an int. It's a string. It's anything in Swift. Even types you make can be optional. So going back to our reading lesson, use optionals where there just may not be a value. So one question is, all right, where does this help you? Where is this actually come to play? So what if you have a reference type, an object, that doesn't exist yet? Well, no. You have a value type, which is, Swift is very heavy on value types. If the value type doesn't contain a value, that's nil. That's nothing. Let's say you run a core dairy cheese. Welcome to Denver. You run a core data query, and it's not a matter of there are no records that match, or there are no objects, entities that match this particular request. It's just like, I don't even see a managed object context. So that's not zero. I'm not returning you zero. I'm returning you, I don't know. URLs don't exist. We've all run into that. A value for a key that doesn't exist. It's not zero. There's nothing. A property you can't initialize, which we've seen if you've ever played with Interface Builder. Casting from one class to another that doesn't work. Or any property that's going to lose its value over time. I mean, we deal with state. We're constantly fighting state. We're constantly fighting with things changing. We're constantly fighting with, I thought this was supposed to be this value, but that means it disappeared altogether. Nothing. So, here's the big question. How do we do it? What magic lies behind the optional? What is this magical incantation, those sorcerers led by that Latner fellow, how do they do it? It's really not that big of a deal. Optionals are enums. They're just enums. That's going to be it. Matter of fact, this is a simplified description. This is what an optional is. An optional is an enum that takes some generic type. They call it T. You could call it whatever. Actually, I think in the true interface, it's like unwrapped. So the option, the type, your generic is called unwrapped. You have exactly two cases. None, which, gee, I wonder what that represents. And some, which means I have a value. And that value is of type T. Did I lose anyone anywhere? Is someone just like, pretty simplistic, really. Pretty damn clever, if you think about it. They just give you an enum, two cases. I've either got a value or I don't. The system knows how to deal with it. So, T, your generic type. Your associated value is of type T. Does anyone not know what an associated value is? It's all right to raise your hand if you don't understand something. Another thing, if I did something and you want more clarification, just tell me. I'll either say it's upcoming, or I will explain. Cool? Yes, sir?
Does that have the same meaning, associated value, like when you're doing stuff you shouldn't be doing in
Not exactly. The associated value is a way of saying, all right, this case is going to include something with it. What it is, not sure yet, but it's going to be there. And I'll actually show you how it gets used, because since they're enums, you can treat them just like any other type of enum. In this case, we do a switch, right? So we have our case none, which is nil, or case sum. The associated value in this instance, we're going to call x. We're going to assign it to the name x, and then we can do something with it. That effectively is what's happening. So does that make a little more sense with idea of associated values? Okay. So in this instance, we create a constant that is an integer wrapped in an optional. We give it an initial value of 10. Then we can switch on it. This code works. Wouldn't recommend typing it. It's kind of, well, no point doing it. But it does actually work. You can type this in. Ta-da! It's an enum, just like any other enum. Just like, the cases of a door, open, closed, not just an enum. So in this case, which print statement is going to print out? The one under sum, because we assigned this enum type a value. So the optional will have a value of 10. Make sense? Pretty straightforward. Optionals can be compared to literals. So that means that in this instance, we create a variable, we don't assign it a value, it's automatically no. And then we say, hey, is that optional integer, is it greater or equal to 0? If it is, then we're going to see the value. It's automatically, the system will look inside that enum and say, oh, is there a value here? Okay, well, I'll pull that out for you and we'll compare it real quick. And then it's going to say, hey, if I try to pull out a value and all I got was case none, then we're going to go with there's no value here. So in this instance, what would you print out? You would print out the optionals no. What say?
You need competitor, right? That's
Yes, you would actually. We didn't pull out X. It was really kind of a carry on from the previous one. But yeah, that's a good catch. If I had a shirt or something, I'd throw it at you. But you get it. So just note that if you don't assign a value to the optional at declaration, it automatically assumes it's no. Which, gee, that kind of makes sense. All right. Syntactic sugar. Using a question mark is just a way of saying this variable or constant, this property, is an optional of whatever type we say with an initial value. So let's look at an example of that. So another incredibly cleverly named variable A, which is an integer wrapped in an optional. It's an optional int. That's the same as saying this exact line. Variable A is an optional of type int with no default value. Or optional of type int, case none. Or, oh wait, sorry, that's a nice line. So, we didn't give an initial value, it means none. Just like if you were creating any class any struct, anything else, if you don't provide initial values and they're not default within your implementation, it comes out as none. It's just there. All right, here's the other part. So let's say we do give it an initial value. That's the same as saying this is an optional of type int initial value 10. Which again, you can type all this out if you want. I'm just saying using a question mark does this for you. Same idea. We're sum associated value 10. So all of these are just the same way of doing what the question mark does for you. So, syntactic sugar. So what if you need to reassign the value? So let's take our friend variable a. We assign it initial value of 10. Then we reassign it a value of 20. That is the same as saying, okay, a exclamation point, which is force unwrapping. Let's reset that value of what you're containing to 20. Or a question mark, which is just saying a of this optional. Let's reset your value to 20. Again, you can do these. Don't, because you'll start to confuse yourself when you go back to your code and you're like, what are all these exclamation points and question marks? Yes, sir.
So the second line from the bottom, a bag equals 20.
Yes.
A is currently empty, it's nil. Will that still work?
It should. It should change. Hey, someone pull up a playground.
You just blew my line.
Really? I mean, it may be unblown if someone runs a, and I look like a jackass, but they'll see it. All right. One thing to keep in mind between a variable and a constant, both of these will start off with an initial value of nil. There's nothing there. So if I take the variable and I change its value, not a problem. If I change the constant's value, not a problem. But now it's a constant. You can't go in and change, even though it's an optional, even though it is an integer wrapped in an enum. Once it is, you say let, once you were saying this is a non-mutable variable, that was not the way to say that, a non-mutable property, it's not going to let you change that. So if you come in here and say, hey, this constant is now 30, it's going to be like, no, that's not happening because the variable can change, a constant can't. Does that make sense? It's just one of those little details that if you're not careful, you will confuse yourself that first couple of times. Questions so far? Anyone? Yes, sir.
So in that case, can you not have a constant that is always guaranteed to be nil? Because you can always change it.
Yes. So if in this instance, if you don't use, if we never assign a value to const, right? It is not going to change from nil. Once we do change it, it is still an optional, so you want to be careful how you're making the assumption about it containing a value or not containing a value. Does that make sense? So once the value is set, yeah, it's not going to change. It won't be nil again. You cannot change it back to nil.
No, it will be nil initially.
Yes, it will be nil initially.
And it will and then but if you change it, you're going to change it back to nil.
Right.
But
And
could you define it as equal nil at the start?
yes, yeah.
And then it will always be nil.
Yes, because it is a constant. So it's one of those it's one of those Xcode warnings that actually at one point will be like, wait a minute, do you want to change this?
So this is a peculiar case because we're combining two different behaviors of optionals. One behavior of optional is that if you leave an optional uninitialized, then it sort of defaults to nil. But then the other behavior of let constants is that you can declare them with their type without assigning their value, but the compiler will be watching your code and making sure that you only assign to it once. And so it's like sort of an ambiguous case in this example as to whether the second declaration, let const stop, is using the behavior of a optional implicitly gets the value of nil as soon as you declare it, or whether we're using the behavior of a let constant declaration, which lets you declare it without assigning to it immediately, but only lets you assign to it once. So if you wanted to assign it, like basically, I don't think that let constants have optionals where they kind of implicitly take on the value nil, and you would have to explicitly say, you know, that const dot equals nil if you wanted to take on the value nil.
That's wrong.
That's wrong?
Yeah, I have a playground open right now. It's
Well,
now
let's
when you
revisit
first-
that.
when you First said it.
We'll
When you
revisit that
first
again.
declared it's now.
Well, yeah, when you it is automatically nil, but then if you explicitly change its value and say hard, this is nil, it should stay. But let's move on. We've got other stuff to hit. This is just thanks, Swift. So just to beat that dead horse, you're effectively taking a type, you were putting it in an enum, and it has become an optional. Remember, it works for not just classes like Objective-C, it works for everything. So you can't do it with class. All right. Then the question becomes, great, we put something in, how do we get something out? Well, you unwrap it. And you have no idea how hard it is to find a picture of someone unwrapping that is not Christmas related or just really stupid looking. So, first, let's look at the bad way to do it. Not the bad, just this is probably not what we're going to do. Force unwrapping. First rule, force unwrapping is the exclamation mark. All right, that's not entirely true, and you'll see why in just a minute. When you see the exclamation point, it's actually one of two things. It's either force unwrapping, or you are declaring an implicitly unwrapped optional, which we'll get to in a minute. But let's say that you have an optional, you want to get the value out. Force unwrapping is, I know this is an optional, I'm going to put an exclamation point in the end, you're going to give me the value and shut up. Xcode loves to offer this as an option. Xcode is like, oh, well, this is an optional. Do you want to wrap the whole thing in a parentheses and put an exclamation point at the end? No. So, if you are going to do this, and there are times that you will do this, and there are times it is legitimate, not a problem. But here are the things to think about. And this one seems fairly obvious. If you're going to force unwrap it, guess what? It's got to have a value. Did I blow anyone else's mind? All right. If you are not 100% sure that the optional contains a value, don't do it. Said another way, seriously, if you cannot guarantee there's a value in there, don't do it. I actually, the project I'm working on now, I actually have forced wrapped two properties in one particular place, only because the bool check I did completely unwraps them and checks that not only did they have a value, but the value is valid. So at that point, I'm okay. I'm comfortable saying, hey, are these two properties ready to go? If they are, I'll just force unwrap it. Is there another way to do it? Sure, but I wrote the code, so leave it alone. Sorry. So here's an example of why it's not a good idea. You create another incredibly wittily named variable called value. In this point, we have explicitly said it's nil, but here's the thing. Even if I didn't put that there, it's still nil. That's the default value, remember? If we just declare it, the system automatically goes, oh, well, it's nil for right now. That's fine. So in this instance, we created a variable, we created another variable and said, hey, we're going to force unwrap that. What we've effectively done is said this variable equals nil. This variable is not an optional. Guess what? We just crashed. I hope you're proud. So the idea is that we just created something and we tried to unwrap it. Well, nil, the system does not like. Therefore, nil causes a crash. So force unwrapping, again, let's go over those rules one more time. Gotta have a value, doesn't have a value, don't do it. Doesn't have a value, don't do it. You good with? We clear? All right. Now let's look at a better way of doing it. That would be if let. This is called optional binding. Remember I said you knew what it was, but you didn't know what it's called? It's called optional binding. By the way, if var works, it was supposed to be removed from Swift 3, but it still works in the playground. Let's go figure. So optional binding. This is in essence what you're doing. If this optional integer is not nil, it has a value, then I'm going to create a constant called a, and I'm effectively going to force unwrap that value, and I'm going to do something with a, right? Otherwise, if it doesn't have a value, then I'm going to do something because it's nil. That is what you were doing with optional binding. But we have a much better syntax for it, which is create a constant called unwrapped if our optional has a value, and then we're going to use it. It does have scope. It's only going to exist for the life of that block or that closure. Right? Just keep in mind that's temporary. It's going to go away on you. So outside of this block, if you were trying to reference unwrap, the system's going to go, no, don't know what you're talking about. So like I said, if var still works, my understanding it was supposed to be removed, but it still works as of Xcode 8 beta 6. Optional binding actually lets you do multiple checks. And they are looked at left to right, because that's how we read. So the first one would be if let the first optional has a value, let's stick it in first, because I'm good at naming things. The next optional, if it has a value, we'll put it in second, but only if first had a value. If the first test fails, it never bothers looking at the second one, because it doesn't care. So you're using the comma like an and. Make sense so far? Okay. You can do the same with the function. So we have a function called, again, my function, that returns an optional int. Well, if I want the value unwrapped of that function, I can do the same thing, because it's returning an optional that needs to be unwrapped. Make sense? All right. You can also do conditionals. Not just if let. You can say, okay, unwrap this, but only if this condition is true. Here's the trick, though. That acts like an and right now. It's actually being pulled out of Swift 3, and it's now just a comma. So it's a little more consistent with the previous example. If you're doing Swift 2 right now, you can use where. Otherwise, it will tell you, no, you got to change that. So just restating it. Where is deprecated in if lets in Swift 3? It'll tell you. You can also do slightly more different approaches. So, okay, if this condition is true, we're going to move on. Then we're going to unwrap where this is true. So that's a little more complicated logic. Is it a good example? Probably not. But you can do it. Plenty of rope here. And remember that in Swift 3 where it disappears. So again, the idea is that it's checking as it goes along. If one is good, it'll go to the second one. If the second one's good, it goes to the third. If the first one was bad, forget it. If the second one was bad, forget it. Everything has to work out to if either has a value or the condition is true and all that. You can also use guard. I'm not going to go into guard and all of its pluses and minuses and everything like that. But say you have a function that has an optional argument. Well, you can unwrap that at the top. You're going to guard that what you received actually has a value. You're assigning it to unwrapped. For the rest of that function or closure, you don't have to try to unwrap the optional argument every time. You know it's there. It's in our constant called unwrapped. We're good. So just keep in mind scope. At the end of that function, at the end of that block, That's disappearing. Again, var was supposed to disappear. It hasn't yet. Go figure. Nil coalescing. Let's get moving along because I think it's a long time. We have an optional string. We have an optional string. We want to see, all right, if this optional value is nil. It's not nil. We're going to unwrap it and assign it. Look kind of familiar, right? Basic idea we had before. But this time, instead of just saying, it's nil, we're going to assign our non-optional string value. So at the end of this if-else, non-optional is going to have a value. It's either going to have the value of the optional string, or it's going to have a default value. At the end of this, it's no, because we never assigned the value. Another way of doing this is a standard C-type ternary operator, which does work in Swift. So we do the same thing. We have the same variables, except in this case, we're going to say, okay, if this condition is true, we assign the left side. In this case, the operational string, optional string, isn't nil, so we're going to unwrap it. Otherwise, we're going to give it the value of no. So at the end of this expression, non-op string, non-op is going to have a value. Well, there's even a better way of doing this in Swift. A cleaner way, if you will. Start off with our same variables. In this case, we're actually going to assign a value to the optional. So non-op is either equal to op string, if it's not nil, or default. So you use double question marks in place of all that if-else. And it will unwrap it for you. And it will assign it, and off you go. See, like I said, you've seen it, you may have used it, you probably didn't know that it had a name. Nil coalescing. Strange name, but there you go. Yes, sir?
Do you know if that's available in Objective-C, the two question marks?
2 question marks? No. You have to do ternary.
Question mark. You can do question mark colon.
Which is a ternary.
Right.
Which is shorthand for the ternary. But question mark. So in this case, it will result yes. You can also stack these things up. If with great power comes not being stupid. You can do this, and the way it works is just the way you think. Hey, if this is nil, then we're going to try to assign fallback. Well, if fallback is nil, we're going to go to all the way out to the default static. So if you want to write code like Perl, where you forget what you just wrote after lunch, this is a great way to do it. So in this case, if both of these are nil, then that let will actually be assigned nil. Make sense? So that's the other part. It's either going to get a value or it's going to get nil. And with optionals, nil is effectively a placeholder. All right, something to keep in mind. Seems obvious, and that's what I'm going to say. Yeah, you can't, if you were hoping constant was going to turn out to be an integer, well, that's not a good idea, because first, this optional, we took it from the previous slide, is apparently a string. That's not going to work, but it has to be an optional. Don't try to put just something there and try to use this as some sort of clever workaround for if-else. It's not going to work. It has to be an optional. Next, the types have to match. So if optional were an int and your default value was a string, you're gonna get a warning. It's gonna say no go. Optional chaining, like I said, you used it, you just didn't know what it's called. This is, according to the book, optional chaining is a process for calling properties not subscripts on optionals that can currently be null. So it's just a way of saying, hey, if something is nil, you have an object, you have a class, you have a struct, you have a whatever, and you get a property. Well, that may be nil as well. That's an optional, and you need to get a property off of that. That's how we deal with it. First rule of training. We never talk about no. Sorry, that's the wrong one. First rule. The result of an optional chain is always an optional. And you may say to yourself, well, that seems obvious. Not exactly true. Because the resulting type will be what you expect, just in an optional. Well, how is this relevant? We have a property called a property, because again, cleverness. That is not an optional. Don't see a question mark. It's a standard int. See? Hey, it's an int. We then set its another value based on property. Well, property is not an optional, but the object that contains it is an optional. Well, guess what? Property, wait a minute, it's not an optional, but now it is because, like I said, the result of an optional chain is an optional. So it has taken that int and it has wrapped it into an optional, right? So let's look at what happens if you were to have, we have an object, the property that we looked at has a value, cool. So that means that whatever the end of the chain was, whatever that property was, gets assigned a value, and it's wrapped in an optional. Same with the function. This function returns an int, but now at the end of this call, this chain, it's going to make that value an optional. You seeing a recurring theme here? So if you hit nil, then what happens? Well, value is equal to nil. Nothing crazy. If along the way, sorry, I don't know what was in there. All right, it works with collections as well. Sorry, it's been a long one. So this is an optional collection. This collection may or may not have a value. Its elements are not. So we get an element out. Hey, look, property is. You get the idea. But let's see where it starts to get a little bit weird. So there's a difference between an optional collection and an optional element. This is saying, give me the element out of this collection, and it's an optional. The collection itself exists, but the value contains the element is an optional. But if we move it, that question mark now means this is an optional collection. What it contains may or may not be optional. In this case, it's not optional. We're expecting a regular value back. Then things get really fun where you have an optional collection of optionals. This gets to the point where you're being a jerk. Just rewrite this so it's more legible as I scan it, not read it. Same with functions. You can have a function that returns an optional value, or an optional function. Optional functions only exist in optional protocols, by the way. Also works the other way. If you're trying to assign the end of an optional chain a value, then there you go. That property is equal to whatever value is. Fourth rule is, if anywhere in the chain you hit nil, the whole thing fails gracefully. The idea being is that if that optional turned out to be nil, you try to assign whatever the end of whatever the property is of that value, well, it never gets there. It never reaches the end. It disappears. So use 2/4. Use optional binding. Before I was saying this is what Xcode recommends for you. Yeah, don't do that. Don't do that at all. Just do an if let, and then do the optional chain. Cool? So, rules are, you're always going to get an optional back. You're always going to get the same type wrapped in an optional. If anything is nil, it fails gracefully, and use optional binding. We are going to have to breeze through if we get to this at all. Implicitly unwrapped optionals. Remember how we said there's the exclamation point, and it's kind of used in two different ways. One is we've seen it as force unwrapped. This is an implicitly unwrapped optional. Implicitly unwrapped optional behaves much like an optional, except that there are certain things it will do an optional will not. So let's look at an example. Variable, hey, changing it up, called x. This is an implicitly unwrapped optional. Underneath, it still acts like an optional. So it still has the nil drawbacks. One thing you can do with it is you can do calculations with it without having to unwrap it if there's a value. Remember, if it's nil, you get a crash. You can compare it for equality. If it's nil, you get a crash. See how I keep saying nil, crash over and over? Not the best approach, but they are very useful. So technically, an implicitly unwrapped optional is of type implicitly unwrapped optional, not optional. So it can still be used with optional binding because it behaves much like an optional. You can reassign it, just don't use question mark and exclamation point. And sorry, that was about don't try to explicitly unwrap an implicitly unwrapped optional unless you know there's a value there. It's just awkward and not a good idea. And let's see if there's. So here's an example you've seen in class with a button. The reason you're doing implicitly unwrapped optionals is because it doesn't exist yet. But you're saying, hey, this is going to exist, and when it does, it's going to have a value, just trust me. So we have a variable that's an implicitly unwrapped float. So then we can't set any of that up until everything is ready to go, until we have made sure the button exists, because I interface builder. Then we can set our value. Does that make sense? So by using the implicitly unwrapped optional, you're saying, look, this value is going to appear. Just give me that. It's also used in two-step initialization, where if you start one initialization process, it requires another to finish first before it can continue. Same idea. Let's see. We'll skip the changes in 3 because, well, while they're not unimportant, they're just not huge. Basic idea in 3, in Swift 3, an implicitly unwrapped optional is going to be pulled out and treated just like a regular value if you're trying to do calculations with it. Otherwise, it's going to act like an optional. Let's get past these. Take over. Basic idea is if you take an implicitly unwrapped optional and you put it in a collection, it's going to turn that collection into a collection of optionals. So real quick, odds and ends. Optionals can be nested. You can see 2 question marks. Question mark. Means it's optional. Or triple. Optional. These are the result of functions that return optional values, returning an optional value. It'll make sense one day. The idea being that if, in this case, we have a collection that has optional elements in it, the method last on collections returns an optional value. So that means that anything, the last item in that collection will be an optional. You can ask me about it later. All right. So if you were printed out, it would actually say optional, blah, blah, blah. You can't use an optional collection. You can't use an optional collection in place of a collection. If you're doing like for in, and you say, we're going to use choices and we're going to try to explicitly unwrap it, it's not going to let you do that. You're going to have to go back and do optional binding to get the value out, and then you can run it. There are optional protocols, and I'm just throwing this in there because it uses the word optional. You have to put obc protocol at the beginning, and any function that you want to make optional, you actually have to put optional in front of it. Look into it. Hopefully you don't use this at all. It's not the best approach. And we'll skip the fact that optionals have their own version of map and their own version of flat map, which I probably lost a lot of people there. And we are out of time, so if you have questions, let me know.